check the validity of the statements given below by the method given against it. In this question we are given two statements and we have to check their validity by the method given to us. We'll solve both the sections one by one. Let us see the first section. The given statement is the sum of an irrational number and a rational number is irrational, and we have to check its validity by contradiction method. Well, before solving this question, it would be fair enough to assume an irrational number and a rational number. So let x be an irrational number and y be a rational number, and we are given that their sum is irrational. So we'll go ahead and assume that their sum is rational, because we know that in the contradictory method we used to assume the opposite of what we are given. So here we are assuming that x plus y is a rational number, which means x plus y is equal to some rational number r, and now keeping x all by itself on the left hand side of the equation, we have x equals r minus y. Now if you observe carefully the right hand side of the equation, you'll find that r is rational as well as y is also rational, as we have assumed y to be a rational number in the beginning of the solution. And we know that the difference of two rational number is also a rational number, which means x is also rational. If you wish, you can write the reason for this. Since the difference of two rational number is also a rational number, which is opposite to our assumption, which is contradiction to our assumption, because we had assumed x to be irrational. So we'll write which is contradiction, which is a contradiction to our assumption. Therefore the sum of irrational number and a rational number is irrational number. So we'll write therefore the sum of irrational number and a rational number is irrational number again. So this completes our solution. Let us see the second section. If n is a real number with n greater than 3, then n square is greater than 9, and we have to check its validity by contradiction method. Let us see the solution for this. First, let us assume n to be a real number greater than 3 and n square is not greater than 9, because in the contradictory method we used to assume the opposite of what we are given, which implies either n square is less than 9 or equal to 9, which can be written as n square minus 9 is less than or equal to 0, which can further be written as n square minus 3 square is less than or equal to 0, and the factors of n square minus 3 square are n minus 3 into n plus 3, because n square minus 3 square is resembling a square minus b square, and we know that a square minus b square is nothing but a minus b into a plus b. So we have written n square minus 3 square as n minus 3 into n plus 3 less than or equal to 0. Now dividing the whole inequality by n minus 3, we'll get n plus 3 is less than or equal to 0. Here we have divided both sides of the inequality by n minus 3. Since n is greater than 3, therefore n minus 3 is always positive, and hence we have not changed the direction of inequality, which means n is less than or equal to minus 3, which is a contradiction to our assumption, as we have assumed n to be greater than 3. So we'll write which is a contradiction, and therefore we'll say if n is a real number greater than 3, then n square is greater than 9 is true. So our answer is, therefore if n is a real number with n greater than 3, then n square is greater than 9 is true. So this completes our solution.